There is an escalator and two persons move down it. A takes 50 steps and B takes 75 steps while the escalator is moving down. Given that the time taken by A to take one step is equal to time taken by B to take three steps, find the number of steps in the escalator while it is stationary. Let me explain the solution now. Let us say that the escalator moves at the rate of n steps per second. Let us also say A takes 1 step per second and B takes 3 steps per second. Let's solve this problem case by case. So in the case 1, when A is coming down, A will take 50 seconds to complete 50 steps. In 50 seconds, escalator would have moved 50 n steps. Total number of steps on the escalator can be represented as 50 plus 50n. So in the case 2, when B is coming down, B will take 25 seconds to complete 75 steps in 25 seconds. Escalator would have moved 25 n steps. In this case, total number of steps on the escalator can be represented as 75 plus 25 n. So total number of steps on the stationary escalator is a constant. Combining case 1 and case 2, we can represent equation like this. 50 plus 50n equals 75 plus 25n. This is because number of steps are constant. After solving this equation, 25n equals 25, n equals 1. So total number of steps equals, consider the case 1. According to the case 1, the equation is 50 plus 50n. Now substitute the value of n, 50 plus 50, which is equal to 100. So the total number of steps is equal to 100. The flag shown here measures 100 centimeters by 60 centimeters. It is divided into two purple triangles and two pink triangles. What is the total area of the two purple triangles? Here, our task is to find the total area occupied by two purple triangles in this flag-like diagram whose area is 100 centimeters by 60 centimeters. The flag is in rectangular shape. Here, the length of the rectangle is 100 centimeters and breadth of the rectangle is 60 centimeters. Let me explain the solution now. In order to solve this problem, let's divide the flag into 4 rectangles. As shown here, a flag can be conveniently divided into 4 rectangles like this. Let's name these divided rectangles as A, B, C and D. If you observe each rectangles carefully, in each rectangle half the area of rectangle is purple. In rectangle A, half the area of rectangle is purple. Similarly, in rectangle B, C, D, half the area of rectangle is purple. Since in each rectangle half the area is purple, we can infer that half the area of the flag is purple. We know that area of rectangle equals length times breadth. Hence purple area is length times breadth over 2 since half the area of the flag is purple. Substitute the value of length and breadth in the formula. Now purple area equals 100 times 60 over 2 square centimeters. After solving this, we get 6000 over 2 square centimeters, and finally solving this we get 3000 square centimeters. Thus purple area in flag is 3000 square centimeters. We can easily solve this problem by conveniently dividing the flag into 4 rectangles. A student got twice as many sums wrong as he got right. If he attempted 48 sums in all, how many did he solve correctly? Let me explain the solution now. Let x be the number of sums student got right. Then the number of sums student answered wrong will be 2x. This is because, as per the question, a student got twice as many sums wrong as he got right. And also it is mentioned in the question that the total number of questions is 48. So the equation becomes x plus 2x equals 48. After solving this equation, 3x is equal to 48 and finally x equals 16. Since x is number of correct answers, so student answered 16 right answers and 32 wrong answers. And this is the solution for this particular problem. If your approach is right, and you can solve this problem in less than 10 seconds. In a family, each daughter has the same number of brothers as she has sisters, and each son has twice as many sisters as he has brothers. How many sons are there in the family? This is an interesting math puzzle. Though looks difficult and confusing, a proper approach will enable to find the solution without any difficulties. I will give the hint to make your job simpler. Here is an hint. Convert each of the sentences into equations using variables. Transform one equation such that one variable is in terms of the other. Substitute one variable in the other equation, obtain the value of the variable and substitute for the other. Use this hint in order to solve this problem. Let me explain the solution in step by step. Let D represents the number of daughters and let S represents the number of sons. It is given in the question that each daughter has the same number of brothers as she has sisters. This can be represented in the form of an equation like this: D minus 1 equals S, and call this as equation 1. D minus 1 because D represents number of daughters, but as per the question, each daughter has the same number of brothers as she has sisters. So in simple words, the daughter cannot consider herself as one of the sisters, hence D minus 1. Also, it is given in the question that each son has twice as many sisters as he has brothers. This can be represented as 2 times S minus 1 equals D, and call this as equation 2. This is because the son cannot consider himself as one of the brothers, hence S minus 1. Equation 1 can be manipulated and written as D equals S plus 1. Now substitute D in equation 2. Equation 2 is 2 times S minus 1 equals D. After substituting the value of D, equation becomes 2 times S minus 1 equals S plus 1. After solving this equation, the equation becomes 2s minus 2 equals s plus 1 and s equals 3. Substitute s in equation 3 to get the value of d. So d equals s plus 1, d equals 3 plus 1, finally d equals 4. Now we have the value of d and s, d equals 4 and s equals 3. Thus, the number of sons in the family are 3. See, converting the sentences into equation is the crucial step in such problems. You can clearly see that this is a clear case of two equations and two variables after conversion. Upon solving, we obtain the values of both the variables. The key is to transform one of the equations such that we have one variable in terms of another. Then the other equation reduces into a single variable equation and becomes easier to solve. On finding the value of one variable, the other can be found simply by substituting. By following these simple steps, we can solve these kind of problems accurately and in less time. Six tigers can catch just 6 rabbits in 6 minutes. So how many tigers will be needed to catch 60 rabbits in 60 minutes? The immediate answer will be 60, but however, that is not the right answer. With mathematics, there is always something under the carpet. You have to look close. Let me explain the solution now. There is a general formula approach and logical approach to solve this problem. I will explain both. Let me explain the formula approach first. If M1 number of people can do W1 work in D1 days working T1 hours each day, and M2 number of people can do W2 work in D2 days working T2 hours each day, then the relation between them will be M1 times D1 times T1 over W1 equals M2 times D2 times T2 over W2. So here in this problem, the given information is 6 tigers can catch just 6 rabbits in 6 minutes. So what we are supposed to find is the number of tigers which is required to catch 60 rabbits in 60 minutes. So for this problem, there are only 3 variables. Hence formula can be written as M1 D1 over W1 equals M2 D2 over W2. Where M is number of workers, D is number of days, hours, minutes, seconds, and W is piece of work. Here catching rabbit is considered as work done by tiger. So M1 equals 6, D1 equals 6, and W1 equals 6. M2 is what we are supposed to find. D2 is equal to 60 and W2 equals 60. Now after substituting all the values, the equation becomes 6 times 6 over 6 equals M2 times 60 over 60. After solving this, we get M2 equals 6. Therefore 6 tiger will be needed to catch 60 rabbits in 60 minutes, and this is the formula based approach. Sometimes the formula is not required in order to solve this problem. So let me explain the other ways to solve this puzzle without using formula. So one way is, so the given information, as we already know, that is 6 tigers can catch 6 rabbits in 6 minutes. According to this statement, 1 tiger can catch 1 rabbit in 6 minutes. In 60 minutes, each tiger can catch 10 rabbits. So each tiger can catch 10 rabbits in 60 minutes, but there are 6 tigers, hence 6 tigers can catch 60 rabbits in 60 minutes. So this is the straightforward approach. There is an alternative method. So consider again the given information, which is 6 tigers can catch just 6 rabbits in 6 minutes. So it is said in the question that 6 tigers can catch 6 rabbits in 6 minutes. If you multiply it by 10, the same tigers can catch 60 rabbits in 60 minutes. So the answer will be 6. So these are the logical ways of looking into the problem, and this is good way to solve the problem if the statements given are easy and variables are minimal. But if the given problem is difficult, then it is better to go with formula approach in order to avoid any kind of mistakes. You need to fill in the gaps with the digits from 1 to 9 so that the equation makes sense. Here the colon means divide. Follow the order of operations, multiply first, then division, addition and subtraction last. There is no complicated maths involved, only basic arithmetic, but it's not an easy one. This problem is difficult even for adults good at math, so it will be difficult for students in grades 3 and even more challenging for students in the islands. All you need to do is place the digits from 1 to 9 in the grid. Let me explain the solution now. The challenge was to fill in the above snake with the digits 1 to 9 using each digit only once. The colon means divide, and you must follow the standard order of operations, meaning that multiplication division comes before addition subtraction. So the best way to solve this problem is through forming equation. Rewrite the snake as an equation. There are 9 gaps. Fill the gaps from A to I as follows. Now equation can be written as A plus 13B over C plus D plus 12E minus F minus 11 plus GH over I minus 10, which is equal to 66. We are trying to find A to I, which we know are some combination of the digits 1 to 9. Before we even look for a solution, consider the total number of ways we could fill in the snake. There are 362,880 possible combinations of the digits 1 to 9 placed in 9 slots. But we can solve this problem easily by simplifying the equation. So we can simplify the equation to a plus 13b over c plus d plus 12e minus f plus gh over I equals 66 plus 11 plus 10, which is equal to 87. So after simplifying this equation, the equation becomes a plus d minus f plus 13b over c plus 12e plus gh over I equals 87. From here we can assume that b over c and gh over I will be whole numbers, and also that we don't want 13b over c to be too big. Knowing this, we start plugging numbers in and seeing where we get to. There is more than one solution. There are many different guesses that will lead to the right number. There are over 100 solutions to this particular problem. To keep the term 13b over c as small as we can, let b equals 2 and c equals 1, which gets us to a plus d minus f plus 26 plus 12e plus gh over I equals 87. And after simplifying, the equation becomes a plus d minus f plus 12e plus gh over I equals 61. The numbers remaining are the digits from 3 to 9. They include the prime numbers 3, 5 and 7. Let's get rid of them as SAP so they don't complicate the other terms. Let's put a equals 3, d equals 5 and f equals 7, which leaves us with 3 plus 5 minus 7 plus 12e plus gh over I, which is equal to 61, or 12e plus gh over I equals 60. The numbers remaining are 4, 6, 8, 9. Playing around with these gets us e equals 4, g equals 9, h equals 8, I equals 6. After substituting, the equation becomes 48 plus 72 over 6 equals 48 plus 12, which is equal to 60. Now we have filled all the gaps. After filling, snake looks like this. And of course it makes sense. One page is torn from a booklet whose pages are numbered in the usual manner, starting from the first page as 1. The sum of the numbers on the remaining pages is 195. The torn page contains which of the following numbers? Is it 5, 6 or 7, 8 or 9, 10 or 11, 12? The most important thing about solving this problem is not just finding the correct solution, but to find it in less time, because that's what it demands in most of the competitive exams. So I am going to teach you how to solve this problem in less time. First of all, it is important to know one of the most important formula to solve these kind of problems, that is sum of n natural numbers. The formula is important here because the pages in the book are marked in the form of natural numbers, that is 1, 2, 3, 4, etc. We know that the sum of all the numbers from 1 to n can be calculated by using the formula n into n plus 1 divided by 2, where n is the last number in the series. Remember, this formula is applicable for only positive natural numbers. For example, sum of first 10 natural numbers is calculated like this, that is 10 into 10 plus 1 divided by 2, which results in 55. In this case, n equals 10. Let's come back to the problem. Since page numbers are represented in the form of natural number series, without doubt, sum of all page numbers including torn page must be greater than 195. Now the task is to substitute for value of n till we get the number which is greater than 195. Now pick some random numbers. For example, first consider n equals 15. Sum of first 15 natural numbers is 15 into 16 divided by 2. This is after applying the formula n into n plus 1 divided by 2, which is 120 after solving. Since 120 is less than 195, we have to choose the other number which is coming close to 195 and it should be greater. So now consider n equals 20, which will result in 20 into 21 divided by 2. This equals to 210. This can be a right number which we are looking for, because for n equals 19, sum results in 190 which is less than 195. Hence 19 must be rejected. Thus number of pages in the book is 20 and now the task is to find the torn page. So now we need to subtract 195 from 210 which results in 15. So what are the two consecutive numbers those sum will result in 15? They are nothing but 7 and 8. Thus answer to the problem is 7 and 8. This is the approach one must follow to find the solution to these kind of problems. So I will show you one more problem which requires similar logic. So the question reads like this. We are given a series of numbers which contains integers from 1 to 50, including both 1 and 50. However, the numbers are in a jumbled form, that is, they are not arranged in increasing or decreasing order, and there is one integer missing. You have to identify the missing integer. How will you find? Let me explain the solution. We know that the sum of all the numbers from 1 to n can be calculated by using the formula n into n plus 1 divided by 2, where n is the last number in the series. In this case, n is 50. So therefore, sum of all the numbers from 1 to 50 is 50 into 51 divided by 2. After solving, sum of all numbers from 1 to 50 is 1275. Therefore, all we need to do is to sum all the integers present in the given series and subtract the sum from 1275. So this is the same procedure that we followed for the previous problem as well. So the difference between 1275 and this sum would give us the missing integer. Because 1275 is sum of natural numbers from 1 to 50 and this number is sum of natural numbers from 1 to 50 without including missing number. Hence, subtracting the sum of given series from 1275 will fetch the missing number. So this is the logic to be used to find the missing number in the given series, provided that the series is positive natural numbers. There are some people on a train, 19 get off at the first stop, 17 get on. Now there are 63 people on the train. How many were on the train to begin with? Even though this puzzle looks very simple in the first view, it can have multiple interpretations. I am going to provide you 3 interpretations on how someone can think about this puzzle. This will help in understanding the approach required to solve these kind of puzzles. Simple way to look into the problem is through math way. As per the puzzle, people remaining on the train after addition and subtraction of passengers is 63. And people who got in from the first stop is 17. And the people who got off from the first stop is 19. Just do simple math, that is remaining passengers minus newly added passengers. This will fetch you the old passengers on the train. That is 63 minus 17, which is equal to 46. Now add old passengers plus passengers who got off from the first stop. That is 46 plus 19, which is equal to 65. So there must have been 65 people on the train in the beginning. This answer is accepted by many people, but since this is a brain teaser, we must be clear on the assumptions. Let's check the second way of looking into the problem. Let's go step by step now. So there are 63 people now on the train after the first station. It represents the combination of new and old passengers. The 17 people that get on the first station are new passengers and are not considered to be on the train to begin with. The 19 people that get off were old passengers but are no longer on the train. If none got off, the number of people that were on the train originally to begin with is 46 plus 19, or a total of 65. Now there are 63 people on the train. How many were on the train to begin with? This can be interpreted as how many old passengers remain on the train and those were on the train to begin with. The solution is the people that are on the train now are 63 minus 17, which is equal to 46, and these are the remnants of those who were on the train to begin with. Thus, the answer is 46 as per this interpretation. Let's get into the final interpretation. So many people thinks that it is impossible to tell the answer to this puzzle with this information. Why they think like this is because the question doesn't state that when the 17 people got on the train, how many stops it has passed, or whether any more people departed or boarded in the meantime. Assuming the 17 people got onto the train at the first stop, when 19 people also departed and the train has not yet left the station. It would be 65 people on the train when it pulled into the first stop. However, to begin with, there would be no people on the train. The train would be empty before beginning any journey. This puzzle can have many interpretations like this. Do share your answer in the comment section. What is most important in these kind of puzzles is to think out of the box. This puzzle can have more than one correct answer, thus the expectation is the correct approach opted to solve this puzzle. The diagram shows two squares. The smaller square has area 18 square centimeters. The larger square has area 50 square centimeters. What is the distance between the two marked vertices? Let me repeat the problem. The diagram shows two squares. The smaller square has area 18 square centimeters. The larger one has area 50 square centimeters. What is the distance between the two marked vertices? Let me explain the solution now. Let P, Q and K be the points shown. We know that the smaller square has area 18 square centimeters. Let's length of each side of a smaller square be A. Hence its area is A square, which is equal to 18 square centimeters. After solving for A equals square root of 9 times 2, which is equal to 3 times square root of 2. Thus, length of each side of a smaller square is 3 times square root of 2 centimeters. Similarly, let's length of each side of a larger square be B. Hence, its area is B square equals 50 square centimeters. After solving, B equals square root of 25 times 2, which is equal to 5 times square root of 2. Thus, length of each side of a larger square is 5 times square root of 2 centimeters. Now, if you observe the figure carefully, QK is equal to B minus A. That is length of side of a larger square minus length of side of a smaller square. Thus, it follows that QK equals 5 times square root of 2 minus 3 times square root of 2 centimeters, which is equal to 2 times square root of 2 centimeters. Applying the same logic to the side KP, the value of KP equals 2 times square root of 2 centimeters. We know from the figure QKP is a right angle triangle. We can apply Pythagoras theorem here. The theorem states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. So by Pythagoras theorem applied to the triangle QKP, we have QP square equals QK square plus KP square. Hence the length of QP in centimeters is square root of 2 times of square root whole square plus 2 times square root of 2 whole square. After solving this, the expression becomes square root of 8 plus 8, which is equal to square root of 16. After solving this, we get the value 4. Thus, the distance between the two marked vertices in this figure is 4 centimeters.
This is what you have for equation, and following are the numbers that you can use to fill in the brackets. They are 1, 3, 5, 7, 9, 11, 13 and 15. You can repeat the number if required. The resulting sum should be 30. Here is the solution. Solution can be achieved in multiple ways. In this video, I will explain two different ways to achieve the solution. So the main issue here is that all the given numbers are odd, and an addition of odd numbers for odd number of times will result in odd number. There are 5 brackets, which is basically an odd number, and all the numbers which are given are odd numbers, and hence the addition of odd numbers for odd number of times obviously will result in an odd number. So in no way will you get an even number like 30 by adding these odd numbers, but we can apply other mathematical operations inside brackets and get the answer. This is the logic to be used in order to achieve the solution for this particular math puzzle. So in method 1, we can achieve the result of 30 by using the minus operator or subtraction operator inside the brackets with the digits. This is how we can achieve the solution using subtraction. Fill the first bracket with 15 minus 9, second with 13 minus 7, third with 7 minus 1, fourth with 9 minus 1, and the last with 13 minus 9. If you solve inside the brackets, you will get the following equation, that is 6 plus 6 plus 6 plus 8 plus 4, which equals to 30. This is how we can achieve the solution using the method 1, using the subtraction operator. In the method 2, the result of 30 can also be achieved by using the factorial of number. Before checking this method, it is important to understand some basics of factorial. So factorial of a non-negative integer is multiplication of all integers smaller than or equal to n. For example, factorial of 3 is 3 into 2 into 1, which is 6, and factorial of 6 is 6 into 5 into 4 into 3 into 2 into 1, which is 720. So let's back to the puzzle. Since factorial of 3 is equal to 6, if we add 3 factorial 5 times, it will result in 30. Hence, fill all brackets with 3 factorial, which results in 30, and this is how we can achieve the result by using the method 2.
Between the numbers 1, 3, 5, 7, 9, 11, 13, 15, 17 and 19, what 5 numbers will make 50? Let me explain the solution now. So the given question is, what 5 numbers out of these given numbers we can take and add them to get 50 without repeating any number. Before proceeding, it is important to understand that it is impossible to get the value 50 using 5 numbers mentioned here, since the sum of any odd number of odd numbers is itself always odd. It would be impossible to pick 5 odd numbers from this list and get 50, which is basically an even number. Let me simplify. All the numbers mentioned in the question are odd numbers. The sum of 5 odd numbers will always be odd. This is because sum of any odd numbers of odd numbers is itself always odd. So there cannot be any possible way in which you can add any 5 numbers from the list given to get a sum equal to 50, which is even. But there are several ways to achieve by performing certain modifications. That is by using certain mathematical operations. One way to do is like this: 13 plus 19 plus 5 plus 7 plus 3 perform factorial mathematical operation on 3. So we know that 3 factorial, which is equal to 3 times 2 times 1, which is equal to 6. Now this will result in 50. So there can be other ways in which you can achieve the solution. Do share your answer in the comment section. Just remember, you can only perform addition operation with certain mathematical modifications. If the same question is asked with little modification like use 5 numbers in the given list of numbers to make 50, but you can add, subtract, multiply, but you are not supposed to repeat numbers. This is pretty simple compared to the previous scenario. By using multiplication operation, we can have multiple answers. One way to achieve is like this: 1 times 3 plus 11 plus 17 plus 19. This will result in 50. Other possibilities are 3 times 5 plus 9 plus 11 plus 15. This also results in 50. 1 times 9 plus 11 plus 13 plus 17 equals 50. 3 times 7 plus 9 plus 5 plus 15 equals 50. 1 times 7 plus 13 plus 11 plus 19, which is again equals to 50. So there are multiple answers. If the condition is given that, you can use addition, multiplication and subtraction operations.